In this TI DLP Labs video, we will discuss the typical luminance requirements for automotive window display applications. We will give an overview of applications on the market today and discuss how to optimize automotive window display systems based on luminance contrast ratio, ambient light, and film efficiency. The details will be talked about later in the presentation. There is a growing interest in automotive window display applications on the market today. These applications require the use of a special window film technology. Different projector and film selection requirements should be considered under different ambient light conditions. For example, a high lumen projector may be required when viewing during the day as the ambient light is extremely high. Automotive window displays have applications when visible to the passengers of the car inside the vehicle, as well as when visible to viewers outside the vehicle. They could be used in the vehicle interior for entertainment or advertising purposes. They could also be viewed externally to greet passengers as they approach the vehicle. Films considered today include holographic optical elements, transparent, switching, opaque, and phosphor film. Each type has its own unique characteristics and should be considered based on the application. Luminance contrast ratio, or LCR, can be used to determine how visible a display is. It is a measurement of image contrast, taking into account ambient light. LCR is a function of three variables: projector light, ambient light transmitted through the display, and ambient light reflected off the display. Factors such as film efficiency, projector output, and the environmental ambient light will have an effect on the LCR. For images to be visible, a minimum LCR of 2:1 is required for automotive display applications. A 4:1 LCR is highly recommended. For example, under ambient light of 2500 nits, a projector light of 7500 nits is recommended for a good quality screen image. Designing for 4:1 LCR under nominal conditions allows the image to remain visible under higher than nominal ambient brightness conditions. In this example, we can clearly see that image quality is not the same for different LCR. The image on the left has an LCR of roughly 2:1, and the image on the right has an LCR of 4:1 due to the smaller displayed image. This resulted in a brighter and better visual image. For lower ambient conditions, it may be possible to trade off LCR for a bigger image size. There are many different types of window display films. The four most common types of film are opaque, transparent, switching, and phosphor films. Opaque films and switching films have a high film efficiency and should be used under high ambient light conditions. Transparent films and phosphor films have lower film efficiency, but their transparency allows for more unique applications. Film selection should be optimized based on operating ambient light condition and the output capability of the projector. To summarize, under high ambient light conditions, a minimum LCR of 2:1 is required for an acceptable image quality. A 4:1 LCR is highly recommended. Film efficiency is one of the main factors that lead to different observed brightness. For applications in high ambient light conditions, the selection of a high-efficiency film, such as an opaque or switching film, will help achieve the 4:1 LCR. A higher output projector enables films to create bright enough images to be seen under high ambient light conditions. For more information and resources on luminance requirements for automotive window display applications, please visit us at ti.com/DLPauto. Thanks for watching.